This is project 13 of Hacking with Swift. We're going to make a tool using Core Image, Apple's ridiculously high-speed image manipulation toolkit. We'll also use again UIImagePickerController, and for the first time UISlider, another UIKit control. For more information, see hackingwithswift.com, where you can buy this video and all the videos in this series as high-resolution videos. It looks so much nicer, particularly for core image stuff. Or you can buy books starting from just $3. You could buy the books, which contain tons of extra information, really deepening your knowledge of Swift as you learn. Please do contribute, it does help me make more videos like this one. Alternatively, find me on Twitter. I am @2straws. If you have questions, problems, suggestions, feedback, general love for my awesome voice, which I'm sure everyone out there is adoring how fast I speak out there, please hit me up, and if I have time, I'll help you out. Again, @2straws on Twitter. So let's begin. We're going to use Core Image, which is a very, very fast way of manipulating images on devices, and we're going to use Core Image to modify pictures, then write them back to the user's photo library. So kind of the opposite of what we did in the Names to Faces collection view project. To get started, go to Launch Xcode, create a new project, and choose Single View Application. For the name, I'll enter Project 13. I don't mind what you choose. iPhone's perfectly fine, whatever you feel like. Swift, no core data, fantastic. Press Next, then save it somewhere good. Awesome. Okay, so to begin with, we're going to use our storyboard to modify how things look on the screen, so we can really lay out the idea of the app. So as usual, please select the view controller, then go to Editor, embed in Navigation Controller. Always looks a bit nicer. Rearrange the storyboard afterwards because Xcode gets it so very wrong most of the time. And now what we're going to do is use the UI view type. We've never used this before. We've used UI image view, UI label, UI button, and so forth, but not UI view. And all of those things, all of those types, all come from UI view. They're all types of UI view. But this is basically an absolutely plain container. It's not a button, it's not a slider, it's not an image, it's just a simple container. It's quite dumb, but that's okay because that's what we want at this point. And what we're going to do is we're going to give it a width of 600, then a height of 430, then x0 and y 64. So it sits just below the navigation bar and leaves some space at the bottom here. When that's done, go to the Attributes inspector and change the background color to be dark gray color, like that. It's a nice color to use when previewing pictures because it gives a bit of contrast to the color in the image. So now we'll change search to be image for image view. Place that inside the view. It's a container now for the image view. And I'd like you to inset the image view so it's 10 points away from every edge. So in the size inspector, that's 10x, 10y, 580 wide, and 410 high. So there's a lot of space around the edge just to show things quite nicely. And while you're here, please change the scale mode from scale to fill to aspect fit so it looks correct. We're not stretching the picture. Don't place anything else more in the gray view. That is basically done at this point. Everything else will go into this white space at the bottom. And what we're going to do is start with the label. So look for label, drag it out, then give it these dimensions: width 70, height 20, and then x 28, y 512. So it places it there. And we'll give it the text saying intensity, strength of something, and make it right aligned so it just aligns next to the label quite nicely so it fills its space very well. Now look for a slider. So that's a label, a slider's here. This is the thing people can touch to drag. Drop it on, and then for this we're going to give it a width of 470, so very wide, a lot of fine grain control here. Then for X, let's enter 104 and Y 508. So all lines up nicely with the thing. You can't change the height, by the way, because it's default for a slider with that thumb in the middle. Now we want 2 buttons, so change slider and search to be button. There's 1. Let's put them both on here. 1, 2. The the first button should be 120 wide, and then 44 high. 44 is, by the way, the recommended minimum for a tappable area according to Apple. 44 width and 44 high is the least you should do, and it is quite large, but keep in mind that iPad mini uses the same resolution as iPad, just shrinks down the available space, so it ends up being sort of 35, 36 just on the iPad mini. So you do want 44 if possible as a minimum height and minimum width. So for this one we want to give it an X value of 16 and then a Y of 540, like that, so it lines up just there. And for its title, I'm going to use change filter, like that. For the second button, give this the title save while you're there, and give it the following sizes, so 60 wide, 44 high, then X 524 and Y 540, so it lines up again with the other one. That is our layout complete. So the image loads here with a grey box around it to help a nice light box look, an intensity slide we can drag up and down, a button to change the filter, and a save button. So it's time to do auto layout constraints. Now I'm using, I think I chose iPhone when I made it, but you may have chosen iPad. How do we make sure this looks great on all devices? How do we make auto layout really functional for this kind of complex layout? And wonderfully, we can make auto layout do literally all the work for us. There is no work for us to do if we ask nicely. So what you do is select the view controller, just click somewhere in there, or click, actually that button there is the best one to choose, or click here, view controller, to select the view controller. And then we're going to go to the editor menu, choose resolve auto layout issues, and then select add missing constraints. And it will add lots of constraints to this. There's constraints all over the place now, like that. See, lots of constraints. But that's it. That really is it. If I play this project back now in, say, iPhone 5S in the simulator, let's see how it looks. I hope you are ready to be amazed. So it's loading it up. And there we go. It's worked first time. If I give the imagery perhaps a red color so you can see it slightly better, not transparent but red. There we go. Play that back just so you can see what it's doing. Perfect. Keeps a 10-point border around it. This is sized down. Go to landscape. Still perfect. Auto layout has made its own constraints for us that exactly match what we want, which is amazing. So there's literally no auto layout work required. And that looks fantastic, by the way, on iPad as well. It's done a brilliant job first time. Now, you might be thinking, wait a minute. I spent ages following the auto layout videos. Why are you only now telling me that this works? The answer is yes, it was remarkably easy. And yes, using Xcode to make your auto layout rules can be a huge time saver, but it won't get it right all the time. In fact, it won't even get it right most of the time. It will often get it wrong. And that's okay, because it's just using a best guess. It doesn't know exactly what you mean, where things should align. It just measures where they were and takes a guess. Oh, stick to the left or stick to the right. As a result, more often than not, you will do your auto layout constraints yourself. In this particular case, it gets it right exactly, which is amazing, and that's why I'm showing it to you. Trust me, I did test this beforehand, thinking, I wonder if it'll get it right, and it did. And that's why I'm using it, but more often than not, it will not get it right, exactly right, not what you mean. So it's just better to do it yourself. And it will frequently, by the way, add constraints more than are necessary. So it will add more than constraints that you would do if you were designing the same thing. So please use it with care and get your designs exactly right. Anyway, before we leave Interface Builder, I'd like you to add an outlet for the image view, so we can change the image here, and an outlet for the slider. So first things first, I'm going to change this back to default transparent background color again. Then go to this assistant editor. Then control drag from there to create an outlet. I'll call this image view. Boom. And then control drag from the slider, make another one. And I'll call this intensity. Brilliant. We also want to create actions for the two buttons, change filter and save. So I'll find some space at the bottom and then drag from change filter down here. And this is called, it's an action, not an outlet. Almost screwed that one up. Change filter. Good. And choose connect. And then again, let's have another one for save. Like that. And we'll call this just save, not outlet, action. Thank you, Xcode. There we go. And we're also going to do something else this time, which is create an outlet for the slider. What that means is when the slider's value changed, it will call this method saying, hey, my value's changed, do something. So what we're going to do is we're going to drag from slider control drag down to here and name this intensity changed. Change the connection to be an action. And notice it now says event value change, not touch up inside anymore. That's the buttons. Value change is for the sliders. So press connect and it will send it across. Fantastic. That is the storyboard. We are done with the layout. Go back to the standard editor and choose viewControl.swift. It is time to do some coding. So we already have two outlets at the top of our class, one for the image view here and one for the slider. We need another property in which we'll store a UI image, the image data containing the image the user selected from the UIImagePickerController. So declare another property called var current image. It should be a UI image implicitly unwrapped like that with the exclamation mark. So our first task is to import a photo from the user's photo library. Now this is basically identical to project 10. So I'm going to only explain the important bits. If you missed out project 10, you should have paid heed to my warning. Do not skip out projects. I will not be explaining exactly what it does here, just the important bits. So first we want to add a button to the nav bar that will allow users to import a photo from the library. So let's put that code in view.load. We say navigation item dot right bar button item equals UI bar button item. Again, I will use dot add just like project 10. Call self and trigger the method import picture. Here, by the way, is where I'd normally add a title for my view controller. So I'd say title equals something like YACIFP, which I'm making stand for yet another core image filters program, because I am a cynic. If you are less cynical, you can call it, say, Instafilter or some other catchy TM name. So import picture does exactly what it does in project 10. So let's do func import picture. Again, I'm not going to explain this to you because you should know it already. So let picker equals UI image picker controller, just like last time. Picker allows editing equals true. Picker dot delegate equals self, and it'll complain because we're not conforming to the right protocols yet. We'll do that in a minute. Then present view controller picker animated true, completion nil. Brilliant. Just like last time. We need to add the conforming to the delegates here, so, and that means UI image picker controller delegate and UI navigation controller delegate. Again, straight from project 10, nothing new there. As before, we have to implement two methods to make the picker useful, one for they press cancel and one when they select the picture. Again, the code's pretty much verbatim from project 10, so it should be old news to you. I'll put it in here. In fact, you can just leave it entirely. It's a silly method. Lesson here, image picker, there we go. Did finish picking media with info. That one, please. So we say var new image is a UI image. Then if let possible image equals info, the dictionary that came in, UI image picker controller edited image. Optional typecast as UI image, then new image equals possible image, else if let possible image equals info, UI image picker controller original image. You are probably copying and pasting rather than typing this because you're not a mug, but I am, hooray. UI image, then new image equals possible image, else get out. This method has not worked. Great. And then dismiss view controller animated. Oops, true lowercase, nil like that. The difference The only difference in this method from project 10 is that when we've finished with the image, we want to save it away to our property called current image. So we want to say current image equals new image. So we have a copy in RAM of the image the user chose, so we can manipulate it later. For cancel, that hasn't changed, so image picker did cancel. There we go, and we just want to say dismiss view controller animated, true completion, true lowercase, completion nil. Great. So that is select the picture, that is person cancelled, that is good to go, and it saves it away. You can go ahead and try and run it out, it should all work correctly. Let's add stuff, yes, access photos, choose good old leafy, and of course nothing actually happens. We can test that it works by just assigning it to our image view. We can say image view.image equals current image, like that, just to make sure it actually worked correctly. So let's try it again. Add leafy, yes, choose, boom, there it is, looking great. That is aspect fit doing its magic. So that is all old code, nothing's new there. From now on, it's time for core image, which is insanely fast, insanely powerful framework from Apple that does image manipulation in so many crazy ways, and it's used in Apple's own apps all over the place, and we'll use it ourselves, and I'll show you a variety of different things it can do, but there is far more. It's one of those things like core graphics or core audio or core motion or core animation, or all of Apple's core things, which are crazy powerful frameworks that I cannot teach you in full. I'm going to teach you a small slice, and hopefully you can Google up the documentation to find the rest yourself. That's my hope. I'll teach you enough to get you moving, get you interested, get you psyched, and you can get on with yourself. So one downside to core image is it's not at all guessable. You have to know what you're doing, otherwise you'll waste a huge amount of time. Just like pulling in pictures, you have to know exactly UIImagePickerController edited image, which is so unguessable, it's terrible. But that's sadly what we're stuck with. So to get started, we have to add 2 more properties to our class. So add this to the top of your class. First is var context, CI context, exclamation mark. The second one is var current filter, CI filter. So the first is a core image context, CI context, which is the core image component that handles image rendering. Now, this is expensive to create. So we can create it once when our app starts up, then reuse it again and again and again over the app, which makes operations much faster. The second is CI filter, core image filter. That is a set of operations that will adjust the picture. For example, we're about to make images go sepia toned. That is a filter. So we want to create both of these inside view.load. So go just before the end of the method, and I want you to write context equals CI context options nil. There are lots of possible options you could pass to this. Do you want color management, for example, turned on? Forget all that, we're doing the basics, so just no options whatsoever. And for current filter, let's create that filter tone thing, the sepia tone thing. So you want to say CI filter, it'll ask you for a name, and you want to specify CI sepia tone. These are all strings, which is obviously very unhelpful, but there you go. So this creates a default core image context, and this creates a basic core image filter. So to begin with, we're going to let users drag the slider up and down to add varying amounts of sepia effect to the image they select. To do that, we need to set our current image property as the input image for the filter. We say, hey filter, this is the image for you to work with. It's input image for the filter. And then we're going to call a method, which we haven't written yet, called apply processing, which will do the actual core image manipulation. So add this to the end of the did finish picking media with info method. That's down here. We're going to say, zap that entirely, that line there, just for testing. Let begin image equals CI image with image, except to UI image, perfect. Current image, like that. And then current filter, set value, begin image, for key KCI input image key. See about what I meant about being totally unguessable? There you go. So what we're seeing here is a new data type, which is this thing here, CI image. And bluntly, for the sake of this project, for the sake of where you are in Swift and iOS, it's the equivalent of a UI image. It's just in core image land. Behind the scenes, it's more complicated than that, obviously, but that's enough for now. It's just a core image version of a UI image. So as you can see, we can create these CI images from a UI image and send the result into the current filter, which is the sepia tone thing we made up here, as its input image key, the thing it wants to work from as its filter. There are lots of core image key constants like this. If you just type in KCI, you will see them all, and we'll use some of them shortly. But that sets the input image, the image it wants to manipulate with its filter. And then we also have to call the as yet unwritten method apply processing, like that. We'll write it in a second, don't worry. We also have this IB action down here, intensity changed. So when the slide has been dragged, we also want to call apply processing, like that. So copy and paste the line in there. And now it's time to actually make this apply processing function. So we'll say func apply processing, parentheses, open brace, close brace. Here comes the actual work of the code, the actual core image manipulation. So what you do is you pass in a value for how much of the effect you want to apply. So we're going to say current filter dot set value intensity dot value. Intensity is our UI slider. So get the value from the slider between 0 and 1 and pass it in for the key called KCI input intensity. How strongly we should apply the sepia tone, where value of 1, i.e. the whole slider, equals totally sepia, and value of 0 is no sepia. Next up, we're going to use core image to create a CG image. CG image is a core graphics image, which is, again, for the purposes of this tutorial, basically a UI image in slightly different clothing. And we can convert that back into a UI image in a minute. So we'll say let CG image, equals context. That's the thing we made up here once, and we're going to reuse it again and again and again. This thing here, make it once, reuse. Context dot create CG image, and it asks us for two parameters. What you want to create it from, what core image it should create from, and we want to say our current filter's output image, so ever the filter's output, and from a rect we want the full size of the output image. So we say current filter dot output image dot extent, the size of the image that's been output by the filter, which of course might not be the size of the image that went into the filter. That's a CG image, not a UI image, and we want a UI image. So CG image, UI image, and CI images, it's just brilliant, isn't it? They're basically the same thing. As far as you're concerned at this point, they are the same thing. We could say let processed image equals UI image with the CG image, CG image. So that converts the CG image to a UI image that we can actually use. And now we're going to apply that to our image view. Image equals processed image, like that. And that completes the method. It's 4 lines of code, nothing terribly taxing. Set the intensity of the filter to be whatever our slider is. Create a CG image from it at the full size it needs to be. Convert that to a UI image, and then place that inside our image view. That's it. Go ahead and run the program now. We're going to import a picture again using the plus button. Select that one, choose, boom, and we can literally drag the slider and see it become sepia toned in real time, and it is that fast on devices. It really is extraordinarily fast, core image, for applying filters, which is wonderful. So we have a sepia tone effect. That wasn't terrifically hard, let's face it. But now we're going to extend the program to be much more interesting using the change filter button. This is going to use your old friend UI alert controller, and we'll fill it with a selection of filters. And when the user selects one, it will update the image. Now we're going to use, or I'm going to use a shortcut for this, which it works perfectly well for tutorial reasons, and it gives you a lot of things to work with. But in your own code, you only want to use parts of it, not all of it, because all of it's quite unusual, as you'll see in just a minute. So first up, the change filter IB action needs to create a UI alert controller. So we'll say let AC equals UI alert controller with a title of choose filter message nil. Alert style is action sheet, i.e. we want to give the user some options they should choose from to continue their action. Now we're going to add quite a few different types of core image filters, and I've chosen these ones because they're very varied and they're very easy to use. So I'll say ac.add action, UI alert action, title, it's called CI bump distortion, and then style is .default. Let me hide these things so you can see my screen more easily. There we go. And then handler will be set filter, like that. Then I'm going to copy and paste this line a few times. That one, again, like that. So we've got loads of filter types. For the second one, we're going to use CI Gaussian blur. The next one we'll use CI pixelate. Then we'll use good old CI's sepia tone. As you might imagine, spelling mistakes on these are bad because it goes nuts. CI twirl distortion, that's a nice one. Then CI unsharp mask, CI vignette, and for the last one, this is just cancel. I didn't mean to press that, whoops. So handler nil. So these all have titles of core image filters that we can use inside our application using core image. And they'll all call this method called set filter that is not yet written, which we'll write in just a second, apart from cancel, which has nil. So let's make that present by saying present view controller AC animated true completion nil. I don't know where this uppercase trues come from. I don't like it very much. Anyway, that correctly shows an action sheet, creates it, and shows it on the screen. It's 7 different core image filters plus 1 cancel button, but still no actual new code. And when it's tapped, any one of them will call set filter, which I've yet to make, of course. Now this will update our current filter property with the filter that was chosen. Then reset the input image key again, because it needs to in order to apply our selected image back to the new filter, and then call apply processing again. So each of these things actually has a core image filter name in its title. As you saw with sepia tone, we create them by the name. So actually our set filter method is really simple. We just need func set filter with an action, of course. We must accept the UI alert action that triggered it all. We make a new current filter to be CI filter with the name of action.title, the title of the thing that was tapped. Then we make a new begin image as before. You can copy paste this from up here if you want to. Equals CI image from our current image, like that, and then put that into current filter. Set value begin image for key KCI input image key. Boom. Bit of spacing like that, and then call apply processing, like that. But don't run the project just yet, because the code has a problem, and it is down here. Here, this thing. It sets the intensity key for the current filter, but the problem is different filters take different keys. For example, CI bump distortion doesn't have intensity as a key. If you try and set it, it will crash your app. It doesn't know what to do with intensity. Now all the filters and the keys they can use and the values of what they mean are all in Apple's documentation. But we're going to take my epic shortcut. We're going to apply 4 different keys to everything and then use a check to see does it support it before we actually add it. So it'll say, does it support intensity? If so, use it. Does it support something else? If so, use it again and again and again. Effectively, potentially applying 4 different values at once with that same slider. So each filter has an input keys method that returns an array of all the keys that it can support. And we're going to use that with the contains method to see if each of our input keys work with that. If it does, we'll use it. So not all of them expect a value between 0 and 1. Intensity does, 0 being none and 1 being max. Some expect obviously much bigger values. So I've had a good go, a bit of a play test myself. So I sometimes will multiply the slider's value to make effects more pronounced. It's your code. You can obviously choose what you want to do later on. So what we're going to do is first figure out what keys we can input for our current filter. And that means making a new constant, let input keys equals current filter dot input keys as ns string, like that, ns string. We can then check whether that array contains each key before using it. So we can say if contains input keys KCI input intensity key, then and only then set the intensity. Now often I do tend to write this sort of thing all in one line like that, just because it makes it easy to read at a glance what's going on. It's down to you how you want to work, but that's how I prefer to write these single line if statements. There are 4 of these because we're going to set 4 different keys like that, so I'll copy and paste it. So if the input key supports KCI input radius key, then we will set that to be our intensity value here times 200, so it goes now between 0 and 200, 4 key KCI input radius key. That's number 2. Number 3, we're going to set input scale key. And it's going to be between 0 and 10 when it's possible, input scale key. And finally, if it supports input center key, we're going to create a new data type called a CI vector. I'll show you now. So this takes a position, CI vector, and it wants an X and a Y value. So for X, I'll say current image dot size dot width divided by 2, and Y current image dot size dot height divided by 2, like that. So the center of the image basically. That's it. So we potentially apply for all 4 at once, but we check which one's actually supported. So we should, all being well, be able to run this now and see how it looks and works. So I'll add an image. I'll choose that one. There we go. Drag the slider. Brilliant. Sepia toning. Then I'll change the filter to be CI pixelate. Oh, and it's crashed. Why is it crashed? Because I've muffed it up somewhere. What did I muff up? What did I muff up? Oh, I know I've muffed up. Look. See, I've got here, does it contain intensity? Yes, use intensity. Does it contain radius? Yes, use radius. Does it contain scale? Yes, use scale. Does it contain center? Use intensity. That is a foolish thing to do, but a good illustration of what happens if you try and set a key that is not possible for core image. So we want KCI input center key. Gosh, I'm slow. Sorry. Let's try again. So we have sepia toning. Hopefully, hello, there we go. Choose beautiful sepia gorgeousness. Love it. Love sepia toning. Then let's go to change filter and choose pixelate. Hopefully, look at that pixelation of the image in real time. Fantastic. Let's try twirl distortion. What's it going to do? Look at that. Again, all being done in real time on the device. It does look just fantastic. Vignette applies a nice sort of dark shade around the edge of the picture. Fantastic, super easy to do. Gaussian blur advanced warning is a very slow thing to do in the simulator. You see it blurs it right out. Oh, not too far. See how slow it is. There we go. That's Gaussian blur. Then there is bump distortion, which applies a sort of bump in the middle of the thing like that. Just gorgeous. So fast too. The speed of that is just crazy. Apple really do magic sometimes. And then unsharp mask sharpens the edges. See, things get much sharper as you get up. It's a bit of an ugly effect actually, but it's good for some blurry pictures. So that shows a variety of filters we can do, and we're manipulating them all using the same slider, which is a really inaccurate, broad way of doing it. Ideally, you want to say intensity is this value, radius is that value, scale is that, and so forth, based on the keys in the Apple documentation, rather than having just one slider. But for tutorial purposes, changing them all at once is super fast. So that is most of the project. The last thing we're going to do is make the save button work. So you've seen how to use up here again and again now the UIImagePickerController class to load images from the photo library. It's now time to save them back to the photo library. And that's done using a function call with, it's a complicated one because it takes some very strange parameters, but it's called UIImage write to saved photos album, which sounds fantastic, but the syntax is pretty grim. So what will happen is it will call a particular method. Image did finish saving with error context info. It's ugly, it's unavoidable, and quite frankly, it's a bit of a wart in iOS. It's one of the things that really does stand out in my mind as being ugly in iOS, which is a good thing because it shows how awesome the rest of it is. So what we're going to do is we're going to use this line of code to write to disk, which is done using in the save method here, and then it will call us back when it's finished writing, so we can show an error or otherwise as needed. It's not pleasant, really. There is no way around it, I'm afraid. So sorry. So here we go. Inside save, you want to call UIImage write save photo album. It takes an image, a target, a completion selector, and some context info, which is terrible. However, let's crack on and use it. What you want to do is for image, well, fair enough, that's easy, that's current image. Completion target, who should we tell? Well, the answer is simple enough, us. The selector, this is the truly nasty bit. You need to write pretty much exactly this. Quote, image, colon, did finish saving with error, colon, context info, colon. Like that. And then context info, I'm going to pass nil. Like that. That's what you should be calling. Just like that. If you don't do it exactly like that, it gets angry. And then it will call back a function for you called image. And it will give you back the result. So we want to call this image UIImage, like that. Did finish saving with error, NS error, context info, and needs to be unsafe pointer void. It really is nasty. I mean, what are they thinking? Anyway, that is about right, I think. Yeah, Swift isn't complaining, so I think that's probably a good thing. Oops, daisy. Yep, it's not complaining. It seems to like it. Good. That's probably about right. So that's the call. It's just, honestly, it is just astonishing. So what it's telling us is this image has finished saving with the error, this thing, and some context information here. That's what it's telling us. We are not using context. We can ignore that. The error is useful. Did it work or did it not work? That is obviously important. And if we get an error, we know things have gone wrong. We can show it to users. If we have not received an error, then fine. It means it worked okay. So what we're going to do is, for the first time, we're going to use this error in a meaningful way. We're going to say in here, if error is nil, so if no error came back, then we want to create a new UI alert controller, the AC, sorry, equals UIAlertController. Title, saved. Great. Message, your altered image has been saved to your photos. Preferred style, alerts, fine. And then add an action. This is all old news to you, I know. UI alert action, title, okay. The style default, handler nil. And then present view controller, AC, animated true, completion nil. So that's if error was nil. We've had no error back. It means it worked correctly. Else, error is not nil. Let AC equals UI alert controller. That's it. Title. This time we want to say save error. For the message, we're going to use error question mark dot localized description. This is an optional error. This is Apple's way of sending back errors. Optional, so we have to unwrap it carefully or get nil back. And that means get the description for this error in whatever language is available for the user. The preferred style is alert still, because what else is it going to be? And then we'll just copy and paste these two lines. Add an OK button to the end. Boom. That is it. Go ahead and run the program now. Add something. Good old Leafy. Choose him. Give him some nice sepia toning. Then press save. Saved. It's been saved to the photos. We can press the home button. Go to the photo library. And it's not there. It's not there. You know why it's not there? It's not there because I'm being dense. Can you spot the bug? Can you spot the bug? I'm going to give you a handful of seconds to spot the bug. Look carefully. You'll see Leafy's there and there now. 5, 4, 3, 2, 1. Yes, sorry, I am yet again being dense. We are writing out current image, which is the image the user chose. That's a silly thing to do. That's why I'm writing the same picture out again. We want to change that to be the image we've converted, which lives inside imageview.image. That's it. That's the change. Hopefully you spotted it. Perhaps you've been shouting at your screen for the last half an hour. We will see shortly. Let's try again. Let's import a different picture. Mr. Waterfall again. Choose. Make him nice and sepia. Look at that. It's just beautiful. Just beautiful. Press save. It saved it. Awesome. Home screen. Photos. Boom. There it is. Sepia max compared to that. That's a huge improvement. So now we have successfully written our sepia tone picture back to the image library, despite my attempt at introducing bugs at the last second, which means this project is complete. This really has been an extremely brief introduction to core image, but I think we still managed to make something quite useful. You know, you've used a UISlider for the first time, and you saw quite a few core image filters. For some reason, core image filter apps do extremely well in the App Store. Apple seems to like to feature a different one every week since the App Store launched, from what I can tell. So there's tons of options out there to make something better and get featured by Apple. So do give it a try. I suggest you do a Google search for core image filter reference and read. That's Apple's documentation that lists all the possible core image filters, including all the keys they take, so you can modify them to your heart's content. As a reminder, go to our website, hackingwithswift.com, for more information. There you can buy this tutorial as a book, which includes a sample code, which is quite helpful, but also includes lots more explanation about core image and how it works. Plus, you can buy this video in high resolution to really enjoy Leafy's sepia toneness. Alternatively, follow me on Twitter. I am at 2straws. Please, if you have questions, suggestions, advice, tips, feedback, corrections, I don't know what, anything but hate, get in touch at 2straws, and I'll do my best to talk to you if I can find some time. I expect you will not be alone.